Bless you.
Bless you. So much fun.
Alright, we need some supplies, so while you guys are copying those down, I'm going to pass out some supplies.
You're recording?
Can I?
Yeah, I usually record third period class, but I forgot to. Those guys on my website, I post the video. Yeah, so if you're absent, remember you can go to my website and watch the video of the lectures.
So can they hear us?
Know what we did. Not unless you're really loud.
Okay.
You pretty much have to have a mic or be near the mic to be heard.
Can I donate the book to
No. You can donate paper out of the kindness of your heart, not extra credit.
Problem.
Wow, that is not straight. Let me try that again.
A+. That was moderately straight.
Okay. How does the A, H, and K affect the parent function? The parent function is some number b raised to the x. Okay, so we have different values that can manipulate our function. One could be an A, which is a value that's being multiplied to the base. One could be a minus h, which means the exponent can have something manipulated. And outside the function, we have a plus k. These same manipulations happen through all of our parent functions. The exact same stuff happens to quadratics, which we just finished. Exponentials are today, and then later this year we'll be learning about other functions like square root functions and cube root functions. And the exact same patterns happen to those. So once you get these patterns down, you should know how all the other functions change, because the exact same thing will happen. Alright, so our parent function is the most basic function. For a quadratic, the parent function would be y equals x squared. That's the most basic quadratic you can get. We're doing exponentials today, which would be y equals some number b raised to the x. Now you guys actually should have experience with exponentials. Because last year in secondary 1, you should have focused a lot on linear, which are lines. You did a lot of lines last year, right? You agree? Yeah.
Sure.
And you should have done a lot with exponentials. Does anyone remember what? Well, let's start up here. Raise your hand if exponential graph sounds familiar. Okay, good. But not together. Okay, well, that's honest. Does anyone remember what a graph looks like for exponential graph? From those who remembered learning about last year? What does a graph look like? Linear is a straight line. What does a graph of exponential look like? Yeah, and it's not straight, is it? It's a curve that grows. We call it growing exponentially because the slope starts almost flat and then it gets steeper, 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 and grows faster and faster and faster. It could also be a decay, which gets steeper, 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 and declines faster, faster.
Doesn't it never touch zero?
Right. So it never reaches zero or negative, unless it's flipped, but it never touches the x-axis. Okay, so Raul, give me a number for b for our base.
7.
Great. Y equals 7 to the x. Okay, just as a reminder of how you write exponents, this is not the same. This is 7x. This is 7 to the x.
What?
They are different. So when you write exponents, don't write them like this one. Exponent should be small. It should be up high in the corner. Okay, so this is not how you write an exponent. Just making sure that's clarified. Alright, so when our base is 7, what's 7 to the first power? 7. 7 squared?
49.
49. 7 cubed?
Good numbers.
I don't know, something really big. Okay, so the larger the base is, the faster it grows. What if this was a 2? What's 2 to the first power?
2.
2. 2
4.
squared?
4.
4. See, that's really small still. 2 cubed? 8. So it's growing less
16,
fast.
32,
Not as
64,
fast.
100.
Okay, so the base tells you kind of how fast it's going to be growing. The larger the base is, the faster it's going to grow. Alright, so for example 1, we're going to graph, which is why I'll give you rulers. I haven't gotten out the crayons yet. We'll do that in a sec. We're going to graph 3 different graphs on the same coordinate plane. So when we do this graph, it has to be large enough that we can hold all 3 and it won't be confusing. So y1 will be our parent function. We're going to start with a smaller number so it's not growing so fast. Y equals 2 to the x. Then we're going to graph a second function, y2 equals 3 times 2 to the x. And the third one, y equals 1/4, that'll be y3, 1/4 times 2 to the x. So they're all 2 to the x. What we're going to be looking for when we graph it is what happens when we have these multipliers. These multipliers are in the spot of A. Yeah. Okay, what were these numbers, or what were we doing? Yep. These multipliers are in the spot of A. So we're trying to figure out when there's multiplier, how does it change the graph? And we should be able to get to a point where we don't even have to graph it eventually. Eventually we can just look at the equation and know what all the different numbers do to the graph. Okay? So, grab your ruler. We need, since we have 3 graphs, 3 equations, we need to do an x, y table for each of them. But we're going to use the same x's, so we're just going to do 4 columns. An x column and then 3 y columns. So grab your rulers so your notes are nice and neat. And I'm going to scoot that one over. Make it straight. I don't think I need it that long. Okay? First column will be x. Second column belongs to our first equation, y1. Okay, it's important that everyone has a calculator available. And so, if you fill out your calculator use agreement, you can come get one of mine. Otherwise, if you're using a cell phone or iPod, you must only be on the calculator, or it will be taken away. Okay, but you do need a calculator out, so please get a calculator.
Instagram form, do we take this home?
You can only use them. Okay, so, does everyone have a calculator? I still see some empty desks. If you're using a cell phone or iPod, it needs to be flat on your desk. So you can see you're not going to anything else. The team is a flat. Put a flat on your desk. Okay, there's still some people with no calculators. Please find a calculator. Come get one if you don't have one. Everyone needs a calculator. Remember, the calculator use agreement form is 20 points to have your own or fill out the form. It goes on your grade. If you already did it last term, congratulations, you have the free 20 points. And you have more forms if you need them. Gerardo, do you usually have glasses?
No.
Okay. Alright, what are the x's we usually graph around? -3 to +3. So we're going to do the same here. Let's fill in -3 to +3. When we graph, we need points, so we need to plug in all of these x's so that we can get points. Okay, so the first equation we're going to refer to as y1, which equals 2 to the x. Okay, we can do some of these in our heads. Let's start at the bottom, plugging in +3. What is 2 cubed?
8.
8. 2 times 2 is 4 times 2 is 8. What is 2 squared? 4. What is 2 to the first power? 2. What is 2 to the 0 power?
0.
No.
1.
1. Anything to the 0 power is 1. When we get into negatives, it's going to be a little more complicated, so let's grab the calculator. Go to the home screen. Oops, what am I doing here? Let's see. It's trying to graph. Okay. Home screen, clear out anything in there. You'll need a 2. How do we do exponents?
Caret button.
The caret, which is above division. Okay, all of the 3 remaining spots are both negatives. We have to have parentheses. So we did -3, we do parentheses, -3, close the parentheses. Press enter and add it to your chart. Okay. Now, do you guys know the copy and paste feature if you have a graphing calculator?
No. That's what
Yeah, if you do second enter, it copies it all. And you only have to change what you need to change, which in this case is -2. And you can just type right over it. You don't have to push delete. Just type right over it. And then hit enter. And we need -1. So again, we do second enter. And change the -2 down and type right over it to a -1. Okay, and fill them in on your chart. And then I can only see one screen at a time, so I'm going to need some help getting these. What did we get with -3? 0.125, -2,
0.25.
and -1.
0.5.
Thank you. Okay, we're going to do the same thing with the next one. 3 times 2 to the x. But isn't 2 to the x the same part as the last equation? So we could use our calculator the whole time, or we could use our brain and just go times by 3. We already have the column with 2 to the x. So you just go through and times by 3. Let's start at the bottom again, because I think that's easier. What's 8 times 3?
24.
24. Does this make sense how we're doing it? It says times by 3, so that's what we're going to do. What's 4 times 3?
12.
Raul, what's 2 times 3?
Let's see. 6.
Good. Okay, 1 times 3?
3.
Okay, now it gets a little trickier, but we can do it without a calculator. 0.5 is the same as 50 cents. If you have 3 parts of 50 cents or 3 half dollars, you'd have
4 half dollars?
$1.50, 1.5. Okay, quarter. You have 3 quarters.
25.
0.75. Okay, this one's a little trickier. 0.125 times 3. 0.375. Right, we have one more to do. Now this one we'll probably just go to our calculator because timesing by 1/4 is the same as dividing by 4. Okay, but with the decimals that's going to get a little crazy. So, let's grab our calculators. We could type in 1/4, but you have to do that in parentheses, which takes 5 buttons because you have to go parentheses 1 divided by 4 parentheses. Or, what's another version of 1/4?
0.25.
0.25. That takes 3 buttons. That's faster. 0.25 times, what was the base? 2. We're going to raise it to -3. Okay? Write that down. That's the longest decimal we'll see. Do it again. Go second enter. And you need to go all the way through your chart down to +3. Fill in the whole table, please. Fill in the whole table. Remember, you can just go, except for it's supposed to be 2.
Oh, that's my calculator.
The base was supposed to be 2. So 0.25 times 2 to the okay, and then if you're doing the negatives, you have to have parentheses. Okay, so you have that one right. Okay, then you go second enter. Change that. -2 to -1. Alright, let's see what we have. So So we did the first one already. It was that long decimal, 0.03125.
Uh-huh.
Okay. Gustavo, do you have the next part? On -2?
No. 0.060.
0625?
Yeah.
Randy, what about the next one?
0.125.
Great. Okay, Perla, next.
0.6.
Okay, let's jump back. Brianna, what do we get when we plug in +1? 0.5. Carlos, what's the next one? 1, and then we get 2. All right, it's time to graph. So I've given you the rulers. Now check out the y's. Are any of the y's negative? No, so we have no need for the negative part of the graph. So we're going to do an upside down T. Now, don't make this itty bitty. We're trying to do 3 graphs on the same coordinate plane, and we're trying to see how they are affected. So don't do it so small we can't understand what's going on. Stretch it out, make it large. And then we need arrows on the ends of the axes. Label them X and Y. What's the smallest value of the x's and the largest value of the x's? Yep, so we're just looking at a snapshot because it doesn't go left and right forever. So we're just looking from -3 to +3. Stretch those out as wide as you can, evenly spacing them. And labeling. Now look at the y's. We know none of them are negative. So how high do we need to go? Yep, all the way up to 24. So I like to make my 5s larger. So 5, 10, 15, 20, 25. Try to evenly space them. Okay, pass on the crayons, please. We'll use them in just a sec, but right now, keep with your pencil. Now we're going to go through and plot these points. So, for our Y1, we ignore the last 2 columns, and we're just focusing on mine are in red, the first 2 columns. Do you need one more?
Yeah.
Okay, Raul will catch. Oh, Raul had to. So, now you guys have extras. That's okay. Almost. You almost made it.
Sorry.
Now it's stuck in
Okay.
wires.
So we need to plot these points. -3.125. Start at the origin, we go left -3, but where is 0.125? Yeah, just a little teeny bit above the x-axis. Just an itty bitty bit above the x-axis. Make sure your points are large enough that when we draw a curve through them, you can actually see the point. Next point, -2.25. Is 0.25 going to be higher or lower than 0.125? Just a little bit higher, just a teeny bit.
That's cute.
-1, comma 0.5. 0.5 should be halfway between 0 and 1. So you come up halfway, again, it's slightly higher than the last point. Okay, go all the way through. 0, comma 1. 1, comma 2. You should notice a pattern that each of them are getting higher. If also you have one that's lower, you know there's an error. I actually did that last period. I made an error because it was supposed to be 0.2 and I had written 2, and all of a sudden there's this jump. Okay, so you make some deductive reasoning to make sure your points look like they should. 2, 4, 3 up to 8. Okay, is this a straight line?
No.
No, it's a curve, and it's getting steeper and steeper. If you watch the steepness, from here it's pretty flat, and then it curves steeper, and steeper, and steeper. Okay, and it will continue that way, and it's growing, so this is exponential growth. What I'd like you to do is take your first crayon, pick a color, any color. I'd like you to color code the column. Color code the column for Y1, and using that same color, you're going to graph the curve through the points you just made. Now be careful. It's approaching the x-axis, getting closer and closer and closer, so you don't dip below. Don't dip below. Okay, so make sure your x-axis, it'll look by your eye like it's being flat on the x-axis, but really it's approaching closer and closer. Also make sure you put arrows on the ends. Arrows on the ends, please. Alright, are we ready for the second one?
Sure.
Okay, now we're going to ignore the Y1 and graph negative 3, 3.75. But we can compare it to Y1. Is 0.375 higher or lower than 0.125?
Lower.
Higher.
0.3, is that bigger or smaller than 0.1?
Higher.
Bigger, just a little bit. So right here, when you graph your next point, you're just a little bit higher than that first point. So they are going to overlap a little bit. The next one at negative 2, comma 0.75. 0.7 is higher than 0.2, correct? So 0.7 is almost to 1, just a little bit below 1. Negative 1, 1.5. 1.5 is between which two integers? 1 and 2, halfway. So halfway between 1 and 2, and now we're getting noticeably higher than the red graph. 0, 3, 1, 6, 2, 12, and 3, 24. When you have all those done, pick a second color, highlight the column please, to color code, so that we know the second column here matches this graph. And graph the curve through those points. Oops, I missed a little bit. Let's try that again. Make sure not to cross the x-axis. Okay, and I have arrows on both ends because it does go on forever, both left and right. Okay, last one. If you're ready, take your pencil again. It's best to do the points in pencil because your pencil is more precise. Let's graph negative 3, comma 0.03. Where is 0.03 height-wise?
Lower than the first two?
Ah, yes, it is lower than the first two, right?
Yes.
It's like microscopically above the x-axis. So to our eye, it will look like it's pretty much on the x-axis. But technically it's just a teeny bit higher. 0.06 is just a little bit higher than the first point, but still microscopically close. 0.125, still really, really close to that x-intercept or x-axis. 0.25. 0.5 is still between 0 and 1, and we don't actually really see much movement until here. 2, 1 is finally when we see that we're stepping away from the x-axis, and 3, 2. Okay, find a third color, color code, and graph the curve through it. Make sure you put arrows, please. once you have all three done, I'd like you to start looking at how did the graph change. My red graph is the original parent graph. What happened when we multiplied by 3? That's the blue graph. What happened to the blue graph by timesing by 3?
Vertically shifted.
It's not a vertical shift.
Dang it.
That comes later. And what happened in the last graph, the green one, when we multiplied by 1/4?
Smaller.
What do you mean by smaller?
It didn't.
It's a fourth the size. Okay. What about the blue one? It got dramatically larger, right?
Yes.
Watch my hand along the blue compared to the red. What's the difference?
You're touching stuff.
Steeper.
Ah, that's the word I want. Thank you. Steeper.
Good job.
And the green one, is the green one steeper?
Nah,
No, it's less steep.
less
Okay?
steeper.
So this multiplier, remember we have different parts that are going to be manipulating the graph.
True.
You're going to see equations with these A, H's, and K's a lot this year. Okay, the A right there affects the steepness of the graph. It's not a constant slope, but it is changing the slope. Okay, so if A is greater than 1, like our blue graph was, did it get steeper or less steep?
Steeper.
What is A?
A is the number, the multiplier. A is the multiplier.
Steeper.
So, for instance, the blue graph was multiplying by 3.
So A is 3.
A is 3. So the blue graph, it got steeper, right?
Yeah.
That's called a vertical
Sharper.
stretch. We get a vertical stretch. When you stretch something, it gets steeper faster. It's getting steeper. That's when A is greater than 1. It could be 1.25 and it still gets steeper. If A is a fraction, fractions are between 0 and 1. Okay? Like our 1/4, the green graph, what happened to the slope of the green graph? Did it get steeper?
Dull.
No, it was less steep. It's like compression. You take a bunch of dough or Play-Doh and you smash it down, it smooths out horizontally, right? It gets wider. That's what's happening here. Okay, it's a vertical compression, which means it's going to get less, it looks less steep. It takes longer for it to make progress going up, which makes sense because we know slope is rise over run. And our rise for the green graph was up 1, and then it ran 4. So for every 4 feet it goes sideways, it only goes up 1. So it's going to be going sideways more than it goes up. Okay, before example 2, we're going to pass out those binders. So let me pause this. Take a little break here. Okay, example 2. Now we're going to look at what the H's and the K's do. We will be doing another graph, so if you don't have room on the front side, flip it over to the back side. Okay, graphing, our first one is 5 to the x. Y equals 5 to the x. Y2 is 5 to the x minus x minus 2. And y3 will be 5 to the x plus 3. So we don't have a multiplier this time. What's changing this time?
The exponent.
The exponents. That's in place of the h.
Okay.
Okay, so we're going to do the same thing we did last time. We need to get some points. So let's draw 4 columns. X, Y1, Y2, and Y3. Taking x from -3 to +3. And to speed this up, we're going to split it up a little bit. So let's have front row. You guys are in charge of plugging in the values into y1, okay? Second row all the way across, you guys are in charge of y2. Make sure your exponent has parentheses for y2. And the back two rows, you guys are in charge of y3.
So we would do,
Okay, Hakeem,
we would do negative
start plugging them in, please.
times 5.
-3.
Yeah. And we'll get all the other values from the other groups. So just worry about your one column.
What?
Worry about your one column. Front row, you guys are all doing y1, the first column. Second row is all doing the second y column. Back is doing the third y column. Okay, so you're plugging in, you're in charge of this one. So you're going to plug in first -3. So you do 5 to the parentheses, -3. What is -3 plus 3? -3 plus 3? They're opposite signs, it's 0. 5 to the 0 power will be what number? Anything to the 0 power is 1. So your first value there is 1. We'll do it again with -2. -2 plus 3 raise 5 to that power. Please do your assigned column so you're prepared to answer the values.
Sure you were, you do it?
Huh?
I don't know for different.
After the 5,
What
do
you
the
get?
next one, it means it carries.
Yeah. That's right.
5. There you go. Okay. You guys, your first one's weird. That's okay. I'll explain it weird in lots of weird stuff. We'll start with it.
Weird Mode Jones. Your character is telling you that the standard scientific notation. Explain what the negative
Okay, hopefully that's enough time for you. The first call, the Y2 people, your first number is weird. I can explain what your calculator is doing. Okay, but for the front row, I need the values for Y1 for our 5 to the X. Let me type this in real quick. Okay, we're just going to go down the line, starting with Jared. What did you get for -3? Oh, you're not Jared, I'm sorry.
No, I'm not.
Parker. Sorry, Fusion. Okay?
0.008.
0.008, okay? Gustavo, what's next?
0.04.
Thank you. Randy?
0.2.
Thank you. Next? Good, Raul?
0.
Mm-mm.
5.
5. Okay, next? Great, and lastly? Thank you. Okay, so the other rows, copy that, add to your notes. Y2. Now this one, I'll show everyone what actually happens. After they copy. I'll give them just a couple seconds and I'll show you. Alright, if we go to the calculator and we type in 5 to the parenthesis -3 minus 2, we get something weird. Does anyone know what that is?
Scientific notation.
It's scientific notation. This is actually, I don't know if I can write on the screen, let's see, 3.2 times 10 to the -4. So it's taking you back to pre-algebra days. Or even maybe in your science classes you've been using this recently.
Yeah, chemistry and physics.
Perfect. Do you know what this decimal actually is? Do you remember what the -4 tells you to do?
Move it 4 places
What's
to the
it?
right.
You said move it. What is
The
it?
decimal place.
The decimal. 4 places to the left. If it's a negative exponent, that means it's a really, really small number. If it's a positive exponent, that means it's a larger number. So to make it small, we go to the left.
So it's...
So it was 0.0032. Did I get enough zeros in there, or are there 3 zeros?
Probably more. 1, 2, 3.
I'll need 3 zeros.
Done.
So the rest you should have been able to get okay. Alright, Kaio, what's -2 when you're putting -2?
0.0016.
Thank you. Alright, Brianna, -1.
0.008.
Okay, Carlos,
1 over 125.
which is 0.004. I don't know, let me see, I think it's... You said 1 over 125? Decimals are easy, that's this last one. Tell me the one you have underneath. 1 over 125 is 0.008. I think it's 0.04.
Yeah, 0.04.
Just 1 0.
Yeah, 0.04.
Okay. What about 1?
0.2.
0.2, okay, just down the row. 1 and 5. Okay, thank you. Back rows. Let's get all the way across to make sure if we've added a new row you didn't have that you're filling it in. Okay, let's start with Gerardo. What did you get when you plugged in -3? Okay. I don't think that's correct. Yeah.
1.
It's 1. Because -3 plus 3 is 0. Anything to 0 power is 1. Alright, Phoenix, what about -2? There's our 5. Okay. So yours might just be shifted up 1 row. Okay, Kiara? I'm sorry? Okay, you plug in -1. What's -1 plus 3? It's the same as 3 minus 1. 2. So 5 squared would be 5 squared. 5 to the second power. Which means 5 times 5. Times. You're trying to add 25. There you go. Okay, who's next? Us? What? 125, I think. And they start getting really large. Sean?
625.
625. Casey?
3,125.
And Hakeem, do you have the last one? Sean?
156,200.
I think that's too large. I think it's like 62,000. What was that case? Do you have it?
Or 15,625.
Okay. Alright, it's time to graph. Grab your rulers. Once again, are any of the y's negative? No, so we don't have to do all 4 quadrants. We just need the first 2 quadrants. So we're going to do an upside down T. Please make sure it's not itty bitty. Make it large enough that you can see what's going on. For tonight's homework, I will give you graph paper. That will help. Label your axes and put arrows. Okay, for the x's, we're doing the same, -3 to +3. So try your best to evenly space those and make them wide enough that it's not cramped. Now, who wants to graph 15,625?
Parker does.
Only Phoenix. Okay. So when you're graphing, we're just going to, because the graphs go on forever. They go up and up forever. They can go into the millions. We're just going to graph the stuff that's reasonable. So I think up to 25 is reasonable. Anything larger than 25, I don't think is reasonable. So we're not going to graph those. We're just going to graph all the ones that are reasonable. So let's take our y up to +25 again. If we didn't have these decimals, I would have said that graphing to 125 would be reasonable. Because you could count by 5s. But since we have these little decimals and we have to see the details, then we're only going to count by 1s and go up to 25. And label your axes all the way up to 25. So our whole goal in graphing this is try to find out by changing the exponent and adding a -2 or a +3. How is that changing the graph? What's being manipulated? Okay, so grab your pencil and graph all 3 of them and color code them, just like we did on the last problem. -3.008 is microscopically close to the x-axis. 0.04 again, microscopically close to the x-axis. 0.2, you're sitting right on the x-axis. Finally, one that moves away, 0.1. 1.5 to 25. After you have the points, grab a crayon, color code, and make sure when you draw the curve, you're not going to dip below the x-axis. So it should be like flattening out against the x-axis, and then curves up, exponentially growing. What would make it be a decay? What would make it decrease instead of grow?
The y.
It's not the y that's negative, it's the a. Did we add that? I think we forgot to add that. If a is negative, it flips the graph. So if you want to put that in right here, so if a is less than 0, meaning it's negative, it flips. That's when it becomes a decay. We forgot to put that part on. When you're ready to do the second graph, okay, 0.00032, microscopically close to the x-axis. All the point zeros are microscopically close. You finally see some movement at 2, 1. And then we get 3, 5. Color code. Take a crayon and color code the column. So for mine, the red represents y2. And I know that, oops, I dipped a little bit below the x-axis. Let's try that again. Do the third one. -3, 1 is actually above all those points. not microscopically close. Finally, we have some points that aren't against the x-axis. And 25, that's as high as we're going to go. So on Y3, you only have to graph the first three, because those are the only ones that are reasonable. Okay, once yours are all graphed, you need to be looking for a relationship. My red one had an x minus 2. How did my red graph change from the blue graph with that x minus 2? What was affected? Yes?
It was increasing at a slower rate.
It looks like it's increasing at a slower rate. However, watch my hands. I'm going to put my, well, it's kind of easier to see on the green and the blue. Let's do the green and the blue. Watch my hands. Are they actually increasing at a slower rate, or is the increase the same? Ah. Remember, the multiplier is what increases the slope, or the steepness. Okay? Any other observations? What does the x plus 3 do for the green graph compared to the blue graph?
Makes it rise. It makes it get steeper.
Oh, we just talked about that. Remember, the steepness is the same. Okay, I'll give you a hint. I'll give you a hint. Focus here, here, and here. Remember, the blue was the original.
It's just smaller, like, portions of each.
Remember, the blue is the original. This red graph is the x minus 2. What do they have in common?
Numbers.
Well, they all have numbers. They have a point that is 5 high. Okay, if this was the original, and we put a minus 2 in the exponent, it's now here. What's happened?
Move.
Moved. What's the word you just said? Shifting. Which direction?
To the right.
To the right. How many spots?
5.
2. It was at x equals 1, now it's at x equals 3. So when the exponent is x minus 2, it's shifted to the right. 2. Interesting. Let's see if there's another connection. With the green one, we have original here at 1. It also has, the green one has a point the same height. And it's been shifted how many units? 3 to the left. So it says plus 3.
That's cool.
So the exponent is showing you the horizontal shift. The only trick with the horizontal shift is when it says minus 2, it's actually going right. Don't we usually think that minus would be left?
Yes.
Yeah, so we have to think the word opposite. Same with the plus 3, we would think would go right, but you have to think opposite and go left. So here's the idea. If it's ever in parentheses, this is the same for a quadratic function, or we'll get the square roots and absolute values and cube roots later. It's all the same applies. If inside the function in parentheses is a plus 3, that means we go left 3. It's shifting left. If it says minus, you go right. So in parentheses, you always think opposite. Okay? So let's write down a couple examples for example 3. And just, we're not graphing anymore. We're done graphing. I want you to just explain what happens without graphing. Explain what happens without graphing. Y equals 4 to the x plus 8. Explain what happens without graphing. 4 is the base, so the base doesn't change anything. What changes the graph is the exponent here. X plus 8. Turn to your neighbor and tell them what the plus 8 does to the graph. Turn to your neighbor. Doesn't just add, the shift. Talk about the shifting, please. How does the graph shift because of the plus 8? Casey and Kaio, you guys can communicate. Casey's right behind you. Kaio, introduce yourself. All right, say it nice and loud. Gabe, what does it do? Shifts left how many? 8. So we call it a horizontal shift. So I'm going to write HS is our abbreviation for horizontal shift left 8 because we think opposite, right? So it's plus, we think opposite. Okay, try this one. Still base 4 raised to the x minus 5. I want you to turn to your neighbor and tell them the shifting. Turn to your neighbor, please. More talking. Turn to your neighbor and tell them how it shifts.
Yes.
And you really do have neighbors because you sit by Casey. So maybe you should tell Casey how it shifts. Okay, Kiara, how does this one shift? To the which? Right, good, because we think opposites. We're going to go in the positive direction. Horizontal shift, right, 5. Does that make sense? Think opposite. Okay, we're not going to graph the verticals because we're just going to talk about them and write them all down. Remember, the generic form. We have an A times a base raised to x minus h plus k. We've talked about the A already. The A affects the steepness of the graph and can flip it. Steepness and can flip if it's negative. The H represents which type of shifting? The exponent represents which type of shifting? Horizontal shift. We abbreviate that with HS. But in our heads, we think opposite. And K is the last piece we haven't touched on.
What?
K is the vertical shift. And for vertical shift, we think same. So VS is vertical, same. So in all of our functions that will go in this order, opposite, same. Opposite, same. If it's inside the function in parentheses, it's a horizontal shift that we think opposite. If it's outside the function, out of the parentheses, it's the same. It's a vertical shift.
So if K is positive, then it will be an upward shift.
Exactly. If K is positive, it says plus 3, it shifts up 3. K is negative, like minus 5, it shifts down 5. Opposite, same. So very lastly, I'm going to write an example that has an A, an H, and a K. And without graphing, we should be able to explain what's going to happen to the graph. Example 4. Last example. Y equals negative 1/3 times 2 to the x minus 4 plus 7. There are 3 different pieces here that you have to explain. Y equals negative 1/3 times 2 to the quantity x minus 4 plus 7. Let's start with the negative 1/3. Please turn to your neighbor and explain to your neighbor what negative 1/3 does to the graph. Turn to your neighbor and explain what negative 1/3 does to the graph.
Flips it.
There's actually 2 things it does, so please explain both. They need to stop. What does negative 1/3 do to the graph? You know each other?
Okay, explain it to me. So because
What's in your notes? Well, it comes in front.
flips, so instead of going up, it goes down.
You wrote something underneath this graph. Explain what
That's
happens.
like 1, 3.
Okay? And make sure you have it all. See if she has
So
it.
it goes every.
That's what you need right there. Now it's your notes. Okay, negative 1/3 is a fraction. And 0 and 1. So what does it do? Compression and...
So like the really short ones, they only go up and they go over 3.
All right. Randy, can you give me one thing negative 1/3 does?
The steepness.
What about the steepness? Does it get steeper or less steep? Not with a fraction. Fractions are less steep. You go up 1, right 3. Or actually, this is down 1, left, Right 3. So it's a vertical compression. Compression that makes it less steep. It also does a second thing. Who knows the second thing? Hakeem?
Does it flip it to,
Yeah, flip, so it's a decay. So it becomes a decay. So it's curving down instead.
Do you have a degree in science?
I do have 2 degrees in science
Why did you take science?
because I specialize in math. Math is a science.
what?
All right, next part, x minus 4. It's in the exponent. Turn to your neighbor, please, and explain what that exponent x minus 4 is showing us. How the graph is going to change.
It's subtracting, so it's going to go down.
4 to the right.
Is that right?
And explain which type of shift it is too, please.
Horizontal shift to the right.
Oh, Proto's very smart. You should ask her this one.
Okay, Susanna, what do we have? What type of shift? Is it horizontal or is it vertical? X minus 4. The exponent. Horizontal shift, so HS. And remember we think opposite, same, so which way would it go? It says minus 4, so you think opposite. Right? How many? 4. And lastly, the plus 7. Who wants this one? Alex? Great. Up 7, because we say opposite, same. Opposite in the parentheses, same outside function. I will be giving you graph paper because you're expected to graph some. Please make sure your graphs are nice and neat. Guys, the homework tonight only has 10 problems. I don't think that is asking for too much. I expect you to actually do your assignment on time. This video will be uploaded to my website, as are all the other videos.
You only put 1 through 6.
1 through 6, and then 20, 22, 25, 26.
Oh, okay.
So in total, there are 10.
Oh, okay.